Pages 115 to 116, you did the review section, numbers 1 to 21, the odd. We'll take a look at those here in just a moment. Make sure you have your books open to page 115 also. As we wrap up imaginary and complex numbers, in general, what are imaginary numbers, Kendall?
Numbers that are numerals.
That's a really lousy definition. Try again. When do we end up with an imaginary number?
With the square root of a negative.
There we go. And by definition, that's actually what imaginary numbers are. Square roots of negative numbers. Of course, the most basic imaginary number of all, Michael? -1. I. The square root of -1. There we go. That's the most basic radicand of all. But the square root of -1, which we will represent, Michael. I. Ladies, it's going to be right after class. We said that if a number is part real, part imaginary, Audrey, then we call it a complex number. Good, a complex number. And with complex numbers, we said to add complex numbers. Page 115 is where we're at, ladies. Very easy. You literally just
add like terms.
Right, essentially like terms, right? Add the real portions, which should be like terms. Add the imaginary portions, which should be like terms. Subtraction, of course, we said just as before, ever since really junior high days, we never really subtract. We add the inverse. Multiplying complex numbers was a little bit more challenging. Maddie, how do we multiply complex numbers? Foil. And when we foil, we're going to end up with an I squared. It's important to remember, Genesis, that I squared is equal to -1. And then for dividing complex numbers, we really have to do what, Kendall?
Multiply by the conjugate.
Good. Multiply numerator and denominator by the conjugate of the denominator. Now, if the denominator is just imaginary, Michael, what do we do to handle that?
Multiply by I.
Good. Multiply top and bottom by I. Of course, if it's real, just do the division. But if it's an imaginary divisor, you would divide or multiply top and bottom by I. Complex, multiply by the conjugate. That's the stuff we were practicing with before. We also looked at quadratic equations and said you could have imaginary or complex values. Remember the discriminant, if it comes out negative, your answers will probably be imaginary or usually complex, really. And then we said rational equations could potentially lead to quadratics, which could have complex answers. Also, another thing we looked at lately with these rational equations is that you could get an answer that doesn't check. And we would call that an answer that doesn't check out. We call it extraneous root, right? An extraneous root. And really the best way to check that is just to determine, you could even do it before you solve the problem, what can't x equal, or whatever the letter happens to be. What can't the letter be? And with rational equations, the key is that the denominator cannot equal Abby. Well, no, they can't equal Abby. Abby says it can't equal 0. Good. The denominators can't equal 0. So if there's a value from the original that would give you a 0 denominator, you know x can't be that. So if you get an answer that says x is that. No, it isn't. It's an extraneous root. So looking at the homework, page 115 and 116, numbers 1 through 21, the odd. Check these last couple here. Good. Number 1, what did you get when you solved this absolute value inequality? It's been a little while since we did these. What's the key to any absolute value, class? Isolate the absolute value set to positive and negative. If it's an equation, you set equal to positive, negative. If it's an inequality like this one, you set either between. When would you go in between the positive, negative, class? Less than. Go outside the positive, negative for a greater than. But in this case, it's a little bit weird. Brandon? Yeah, here it's greater than a negative. Well, when does absolute value, what do all absolute value solutions end up being, class? Positives. When is a positive greater than a negative? Always. Hence, all real numbers. Contradict yourself there. Number 3, to isolate the absolute value, what did we have to do, Maddie? Good. Or you could think of it as multiplied by 3 halves, multiplied by the reciprocal. When you did, you got the absolute value of 2m negative 1 to be greater than or equal to Multiply by 3 halves. Yes. 18. And so we need to go in between the positive negative 18 or outside the positive negative 18. Outside. So we're going to put the 2m negative 1 less than or equal to the negative 18. And we're going to put the 2m minus 1 greater than or equal to the positive 18. That would put it outside the positive and negative 18s. And of course, in each case, we'll put a positive 1 over here, give me 2m is less than or equal to negative 17 here, 2m greater than or equal to 19. And then we just divide away the 2, and there are our two solutions when we divide the 2's away. Do want to write this in the interval notation, though. How would I write that, Genesis? If m is less than or equal to a negative 17 halves. Well, think about it this way. Less than means getting smaller and smaller and smaller until eventually you get all the way down to negative infinity. So that's actually where we want to start, is with our negative infinity, and then reach to the there we go. Now, how do I punctuate, if you want to call it that, my inequality interval?
A bracket.
Where?
The negative 17 halves.
And they're always what on an infinity? And then over here, if m's bigger than the 19 halves, bigger means it gets bigger and bigger and bigger all the way till it gets to. So how would I word that?
19 halves, infinity.
There we go, going up to the infinity, and again we'll put a
parentheses on the infinity and the bracket.
And there we go. How many had this answer on number 3? Forgot to ask, how many had all real numbers on number 1? Are there any questions on 1 and 3? Any questions now that we've gone over them? All right, let's take a look at number 5. What did we get when we added those, Audrey?
24 minus 31i.
Good, 24 negative 31i. Number 7, we had to, well, what's the key to working with imaginary numbers, class? Pull out the I. So when you see that square root of a negative, meaning an imaginary number, pull out your I. What do we end up with for our answer, Michael?
Negative 3 times the square root of 35.
Good, negative 3 times the square root of 35. Number 9, have to multiply those two complex numbers together. Kendall?
4i plus 2 all over 1.
I am not sure what you... Oh! That was number 11, I think.
Oh, I'm looking at
That you did. How about number 9?
34 minus 8i.
34 negative 8i is correct. Now, I didn't quite, because I was so thrown off, I didn't quite catch the full answer you gave us for 11, but something doesn't quite sound right. What did you say your answer was?
4i plus 2 all over 1.
Ah, okay, I know what the problem is. So you got to a 4i positive 2 in the numerator, and you had it, because initially you multiplied top and bottom by I, right? Let me just kind of go back. That means gave you a 36i negative 18i squared all over 9i squared, correct? We knew that I squared becomes
Negative 1.
and negative 1 times negative 18 becomes positive 18. Now then, here I squared also becomes
Negative 1.
which makes this a
Negative 1.
careful then. So when I divide a 36i by negative 9,
Negative 4.
negative 4i, and when I divide an 18 by a negative 9,
Negative 2.
and we want to put that first, real, then imaginary. So negatives because of the negative here, and then also put the real before the imaginary. Does that make sense? All right, question, how many had 5, 7, 9, 11 all correct? All right, any questions on 5, 7, 9, or 11? Questions at all on those? Yes, ma'am.
4 minus 2i.
4 minus 2i. Did you multiply the I by the top and bottom?
No.
Okay, what? Did you just try to divide straight up?
Yes, I took with the original, I took a 3 out of everything and took a 3 out of everything again.
Okay, so you basically took a 9 out of everything. That would have given you 4 negative 2i all over I, like that? Okay, so the only thing is you can't leave this. Remember we said if I had like a 5 over the square root of 3, I said you can't do this because it's a radical. Well, technically, that's a radical. So you can't leave an I in the denominator, so we have to multiply by another I, right? Multiply by I to get the I squared. That's where the negative 1 comes from. That's why we got to clear it out. So again, if you've got an I in the bottom, multiply top and bottom by I. If you have a plus bi in the bottom, multiply top and bottom by a negative bi. Does that make sense? By the conjugate. So complex conjugate, just something imaginary, just multiply by the I. Now, had it been a 9, then we would just divide straight up, right? So, give me another one real quick. Let's suppose we had a 5 negative 20i all over 10i. Again, it's not complex technically in the denominator. It's just imaginary. What do we got to do?
5.
I could, to get what?
1 minus 4i all over 2i.
But we still have the issue of the I in the bottom. You can't have an I in the bottom, just as you can't have a radical. So we multiply top and bottom by
Negative I.
doesn't even have to be a negative I, just a plain old I. But you could, I guess you could do negative. There's something to that actually. Let's just do an I. I think it'll make life a little simpler here. Just multiplying with the I. What does that give me now?
1i minus 4i squared all over 2i squared.
And we got to remember that I squared is.
Negative 1.
So each of these I squares becomes a negative 1. So this numerator could be rewritten now.
1i plus 4.
And the denominator.
Negative 2.
And now I could divide. So here when I divide the reals,
Negative 2.
and I can't really divide the imaginary, can I? So we'll just leave it as a fraction, negative 1/2 I. Does that make sense? All right. Good. Any other questions on the 5 to 11 odd? All right. Number 13, quadratic equation. Factoring, formula, or completing the square since it is complete. What are you thinking, Maddie? Yeah, I don't want to complete the square, and I don't see a way that a 5 and 2 with all positives like that could give me a 3. I would need a negative somewhere in there, and it's not going to give it to me. So I would use the formula. What's A, B, and C? And for our formula, normally say x equals, we'll say v equals, class. Say it with me. Negative b plus or minus the square root of b squared minus 4ac all over 2a. When we plugged in the numbers, Maddie, in for the negative b, you put?
Negative 3.
Plus or minus the square root of?
9 negative 40.
All over?
4.
And the 9 negative 40 becomes a?
Negative 31.
But I don't want to leave the square root of a negative. I'm going to get?
Negative 30 plus minus that plus square root of 31 over 12.
And there we go. How many had this answer? For number 13. Questions on 13. I'm sorry?
Negative 31.
You just left the negative 31. So remember, anytime you see square root of a negative, pull out your I. Looking at number 15. It's almost stupid easy. What is that thing, class? Proportion. And honestly, here, you don't even have to cross multiply, right? Like, you just see what it is. What has it got to be at for X class? 4. That's like what junior hires would do, and they'd use the equal ratio method. They'd say, well, we go from the 6 back to the 12 times 2, so 2 times 2 gives 4. Got to be a 4 over there. Number 17, not quite so much. And number 17 is ghastly. Frankly, it looks awful. Got the x plus 3 over the x squared negative 9 equal to 2x negative 5 over an x squared plus 2x negative 15. This thing's horrible. Thoughts on what we would do here? Kendall?
Could you factor?
I could factor ahead of time. And how many did think to factor ahead of time? That's going to help us as long as we're careful with something. So obviously the numerators aren't factoring here, Kendall, but the denominators do. So the x squared minus 9 becomes?
X plus 3 and x minus 3.
And the advantage of factoring here, Kendall, is we can clearly see
The x plus 3 is cancelled.
so that the left-hand side of my equal sign becomes a 1 over x minus 3. However, when you cancel away something, we would need to specify,
X equal negative 3.
all right? And then on the other side, of course, we have this 2x negative 5. And down here we could also factor.
X and an x plus or minus 5 and 3.
And then here also we would have the x positive 5, x negative 3. Resist the temptation to cancel these two x negative 3's for now. But to solve the proportion, we have to do what, Kendall?
Cross multiply.
And when we do cross multiply, if I were to leave this in the factor form, 2x negative 5, x negative 3, and of course here, it's just going to be what we just had, right? The x positive 5, x negative 3. Here we see that I could divide the x negative 3 away from both sides. But again, if we're going to divide that away from both sides, there we also have to set this unequal to 0 as well. So again, x cannot now equal class a positive 3. So now all that's left is a 2x negative 5 equal to an x positive 5. How many got to this point this way? This isn't necessarily the way I would recommend doing it because you're treading on thin ice when you cancel away variables like that. We'll get to that later. But how many did that? Okay, nobody. I thought Kendall, okay. How many at least canceled this part? Okay, so some of you, so Kendall, you did not cancel the x and negative 3's here. Okay, let's go back then. Let's rewind. You could have, well, yeah, we'll finish up. Could have done it, again, the algebra guy in me says that's usually a bad idea. It happens to work out here because of the fraction. So Kendall, here when you multiplied, the factoring here didn't really do you any good, which I'm guessing, as you were giving me this answer, that was quick. When you gave me this answer, it seemed like you had to think about it because you didn't actually factor this one earlier, which would have saved us a ton of time multiplying this times 1, right? So when I multiply here, it's just going to go back to giving me the x squared positive 2x negative 15, right? And then here, when you multiply, that gave you
2x squared minus 15.
Careful. From your paper? You didn't FOIL that? For first, outer, inner, last?
No.
Negative 11x positive 15, maybe?
Oh, yeah.
Yeah, you did have that on your paper. Okay, yeah, so careful to FOIL here, okay? And at this point, we would want to set the equation class equal to 0. And if we bring the x squared over class, it moves over as a, to just give me, bring the 2x over as a negative 2x to get, and be careful here, when you bring the negative 15 over class, it becomes a positive 15 to get a 30. Now watch. When we backwards FOIL this, Kendall, I assume you got to that. What were your two factors?
X and then x plus or minus.
Ooh.
No.
Should be the same.
Negative.
Should have been both negatives.
And then 10 and 3.
10 and 3. And so you end up with two possible answers for x.
10 and
10 and 3. You would have, if you hadn't canceled anything, you also would have had negative 3 as a possible answer. But remember, we said x couldn't be negative 3. Furthermore, because x negative 3 was in a denominator, we'd already concluded not only could I cancel them, but x also could not be 3. So the only answer left would be the 10. Now again, the reason I say this is if you have matching denominators, they could cancel each other essentially, because in the cross multiplication you get the factors equal. You don't want to do that with numerators, so it's kind of a, again, I would generally avoid that, but the straight up and down reducing certainly could do. How many figured out 10 was the only viable answer? How many had 10 and 3 as your answers? You had both of them. All right? Questions on this one. How many did no canceling at all? You actually double distributed and double distributed. Wow, okay, several of you, all right? I want to look at that real quick if you did. So we got a 2x cubed, negative 5x squared, negative 18x positive 45 from the means. And then the extremes, oh heaven help us, x cubed, 5x squared, the negative 9x and a negative 45. Does that sound right? You double distribution people? All right, and mercy me. All right, so, well, I'm sorry?
Cancel 45. Oh, wait.
Well, one's positive, one's negative. I don't think we can cancel that. Bring the x cubed over as a negative to get x cubed. Bring the 5x squared as a negative to get negative 10x squared. Bring the negative 9x over as a positive to get negative 9x. Bring the negative 45 over as a positive to get positive 90. All equal to 0. Now, this goes a step ahead of where we're ready for. Yes, ma'am?
It's a positive negative 9x.
Positive 9x.
Not negative 9x positive.
Okay, well, I bring this over as a positive 9x, but I put that here, and that gives me the negative 9x. Does that make sense?
You already did it in your head.
Yeah, I was combining as I brought them over. Because I'm showing in fast mo instead of slow mo. Now, this is not quadratic. But, like a quadratic, it's set equal to 0. Now, we could factor by grouping. Here we have a common x squared, leaves you with x negative 10. Here we have a common negative 9, which gives you x negative 10. So you end up with an x negative 10 and an x squared negative 9, which becomes an x negative 10 and an x positive 3 and an x negative 3. Again, all of this equal to 0. So you set each factor equal to 0, and you get 10, 3, and negative 3. But these two come out extraneous. I think they wanted you to do some canceling. Surely they did, because this is still coming. We're not there yet. So surely they wanted you to cancel some stuff. Questions on that? All right, so maybe write some stuff down here. With rational equations. Okay, so let's kind of make a list of some things here. Number one, if you can factor and reduce within a fraction, do so. Try to factor and reduce within a fraction. You can always do that. That's never going to lose you an answer. You can also cancel matching denominator factors. You can also cancel any matching factors that are both in denominators. But again, I told you, you're getting kind of sketchy when you're canceling opposite the equal sign because you can't cancel numerator factors. That's literally where your answers would come from. So do not cancel matching numerators. And the only reason you cancel denominator factors is they already couldn't equal 0 anyway. So you're not losing anything by canceling them. You cancel numerator matches, you're in big trouble. Like for instance, if I had an x plus 2 over times x minus 1 over 3x negative 7 equals x plus 2 x negative 4 over x. See how the x plus 2's match? But they're numerators. Don't you dare cancel those. Does that make sense? But just making sure you're paying attention now. But that was a chalk drop. I don't have a mic, so I did a chalk drop. All right. Do you see here they're matching denominators? Now you cancel them. Or x plus 2's match straight up within the same fraction. There you can cancel. Does that make sense? Straight up and down you can cancel. Okay, you're just reducing. We can always reduce. Matching denominators. Go ahead and cancel those. But not matching numerators. And it broke the chalk inside the chalk holder. That's just sad. Wow. All right, questions on that. I had a conductor one time in orchestra. You know, conductors for band often carry a baton. But she was deadly because she would lose her grip on the baton all the time. And the baton would go flying. And it's just, you never knew, depending on if she was coming down, it would hit the front row. It was going up, the upbeat or side beat or I tell you, it was dangerous. So she started using highlighters because they were easier for us to see if they came flying at us, and it didn't have the long, sharp, stiletto type point, to impale one's. Anyway, of course I just hit a chalk tray, not Maddie. All right, you're welcome, Maddie. All right, questions on this? Let's take a look then at number 19. See a little tiny piece of chalk. That's no good to anybody. Another small piece of chalk could be useful later. Another small piece of chalk could be useful later. But when it's really small, it's just worthless. Why are y'all looking at Kendall and laughing? Come on now, that's just mean. That's just mean. Kendall is a sweet, wonderful person. We are so thankful she is in our class. All right, let's take a look at number 19. I'm going to miss you when you graduate, Kendall. You know that, right? But all these short jokes I've been using for years, I'm like, when Kendall graduates, who do I pick on with all my short jokes?
Gabe.
But watch him grow. Like, have you seen his dad? He's like this big. Okay? Mom's short, though, so maybe he stays short. I don't know. I've got a feeling his growth is coming. So, anyway. We love Kendall. All right, number 19. Number 19. We have r negative 4. And I'm just going to start off with the factored form of r squared negative 16, class. R plus 4, r minus 4. All equal to 5 over r minus 4. Again, you could either cancel these two r minus 4s because they're straight up, or you could cancel these two r minus 4s because they're both denominators. If there were an r minus 4 up here, you would not cancel those two. We got all three rules down? Okay. Or you could just straight up multiply and not worry about it, and that way you don't risk it. But last time was rough. This time really wouldn't be that bad. But I want to cancel. Which ones do you want to cancel? Kendall, since I went and picked on you?
The top and bottom.
The top and bottom. Okay. So we can specify r cannot equal 4. But we already knew r couldn't be 4, right? Also, because of this, we know r cannot be class negative 4. Let's go ahead and solve from here. My new equation is 1 over r plus 4 equals 5 over r minus 4. Now it's going to be really easy to solve. We cross multiply Audrey to get
5r plus 20 equals 4 minus 4.
we bring the little r over as a negative r. We send the 20 over as a negative 20. Here we're going to get class 4r is equal to, and r is equal to,
Negative 6.
that wasn't one of the rules, that wasn't one of the things I couldn't get, so there we go. How many r equals negative 6 for number 19? And it would also get r equal to a 4. Okay, and again, we see that that couldn't be the case. If we hadn't canceled, though, it's an answer you would have got. It's the extraneous root. Questions on 19? And number 20, how do we write that thing as an equation, Michael?
Well, I got a lot of scribbles here. So, like, I got 13y plus 3 equals 20y plus 80, but
I think you originally had it over a y plus 4 all equal to 20, which you put over 1, and then you cross multiply, and that gave you a 13y plus 3 equals 20y plus 80, which is correct. Good. I could see what in the scribbles, I've got great vision like that, even from up here. I just can't hold on to a chalk holder. Or remember to mute my cell phone during chapel. All right, anyway. All right, go Irish. All right, so now what do we do? Genesis?
Get rid of the 13y. Negative. To get 7y. Plus 80
Well, let's bring that over here.
as a negative. Negative 77.
And then we divide away the y, we get
Y equals 11.
close.
Negative 11.
Negative 11. Y equals negative 11. The only thing y couldn't be before, by the way, was a negative 4. It's not. We're good. How many of y equals negative 11 for the answer? How many of this equation, as well as proportion? Questions? Yes, sir.
Well, we have to specify the cannot equal on the quiz.
Only so far as to make sure you don't list an extraneous root for your answer. Because if you circle an answer that's extraneous, obviously you lose points. But no, otherwise no. Good question. Any other questions? All right, let's give you a chance to go back and do the evens now, 2 to 20. We already did 22 the other day. We'll do 2 through 20 the evens on pages 115 to 116. For sake of time, let's just go to 14. Let's just do this page. Friday, I'm too lazy to do 42 times 35 in my head. Looks like most of you are about finished. Pencils down even if you're not. Let's take a look at these together. The first two inequalities, both of them were less thans. One's a less than or equal to. Really doesn't matter because both times we're going to go inside the positive negative. We get the absolute value rather isolated with the 28, go inside the positive and the negative 28. And when you solve, you get everything between negative 15 and negative 7 in parentheses. Here, everything between, it's ugly, negative 34 thirds and 22 thirds in brackets. How many got these two correct for 2 and 4? All right, questions on the work. I tried to show the steps. Any questions on 2 or 4? All right, if you did not get it, did you find where you made your mistake?
I tried to do multiply. Well, I did it multiply everything by the LCD.
Oh, okay, so you try to multiply everything by a 4.
Yes.
The key there, this is all one big thing, right? Because it's all grouped. So when you multiply by 4, that knocks out this, but you can't also then multiply another 4 in there. Does that make sense? All right, good question. Good. Any other questions, comments on these? All right, now to the more recent stuff. Subtracting imaginary numbers. Nope, add the inverse. How many got the negative 54, positive 39i? Questions?
I didn't dot my I's. I thought it was 81.
Oh, okay, all right. And then here, this is just obnoxious, right? I squared of 42, I squared of 35, this I squared of 1,470. Now, I immediately knew there was a 49. How did I know there was a 49?
You had all the numbers 1, 4, and 7.
I did? I didn't think so.
7 can go into 14 and 7.
That's another way to think of it. Actually, I saw there's a 7 in this and there's a 7 in that. So for instance, if I were multiplying a 15 and a 10. Well, there's a 5 in both of those. I know there's going to be a 25, right? If you've got a 27 and an 18, there's a 9 in both of those, so there's going to be an 81. Anyway, that's how I spotted the square. I realized there was a 7 in both. That's another way. 14 and 7 both have 7. Anyway, so we get the 49 times 30. However you ended up with it, it's the only good square to use. End up with negative 7. Here's the negative 1. There's the 7, negative 7, and there's the 30. How many got that? However you arrived at the 49. All right, the other way is 4 doesn't work, 9 doesn't work. You know 16 ain't going to work because 4 didn't. 25 doesn't work. 36 won't because 4 and 9 didn't. 49, oh, 49 works. You know, so you can just do a trial and error as well. Over here, the FOIL ended up with a 9 plus 15i. How many had that answer? And then on the last one, you multiply by the conjugate this time, 3 negative I, end up with 25 plus 25i all over 10. Reduce it down, 5 plus 5i over 2. How many got that for the last one, number 14? Any questions for it?
That's 12.
Or 12. Oh, I didn't fit it to, 14. Yeah, that's what I was doing. I was saving 14. Let's take a look at number 14 together. I tell you, it's Friday. I'm struggling. All right, number 14. Just in class now. We have 3h squared positive 5h positive 4 equal to 0. Once again, class, we're stuck using the formula. So we've got negative b plus or minus the square root of b squared minus 4ac all over 2a. And with a negative 5 plus or minus square root of
22.
negative 23, but I'm not going to write, I'm even too lazy to write negative 23. I'm going to write I, and then the square root of the 23 all over 6. And we're done. And how many had that for number 14? All right, questions on 14. Yes, ma'am.
Oh, I did.
That was a late hand, you got it, okay? All right, questions on this. All right, clear dust except for a clean sheet of paper, pencil, calculator, everything's laying. First last name at the top of your paper along with today's date. First last name, top of your paper along with today's date, which is 11/12/21. 11/12/21, today's date. Yeah, this is quiz 15. Quiz 15. So we're going to take a look at the quiz together very quickly here. 1 through 3, answer the questions. Numbers 4 through 12. Simplify. Obviously the first few just fundamental or non-fundamental, I should say, powers of I, which you're simplifying. Then you got some imaginary numbers you're adding, subtracting, multiplying, and then some complex numbers you're working with there. Then 13 through 15, solving those equations for x. All right, you may begin. All right, the homework on the board, and then we'll end the video here.